Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about how you can rapidly fine-tune anti-roll slosh tanks in ProteusDS. So what we're talking about here is an anti-roll slosh tank. Usually there's something like a box with water in it, and when properly sized and properly tuned with the right water height, you get a sloshing wave going back and forth that goes back and forth at the same rate of the roll natural period of the ship. So you can read a little bit more about how you go about the tuning process and sizing process in this blog article, for example, which I'll put a link in the video description. But generally speaking, what you want to try to do is make the tank as wide as you possibly can on the ship. And you need to have a good amount of water in that tank, something like 2 to 5% of the displacement mass to have a reasonable impact on the ship. But then the real trick is finding the right water elevation that gives you the right wave speed to line up with the ship roll motion. So for this example, in the ProteusDS ShipMo3D toolset, we're going to use the generic offshore supply vessel. This ship has normally, it does have bilge keels on it already. I'm going to leave those on. I'm not doing anything fancy about those. But really we're just talking about adjusting the tank. It's about a sort of 15, 16 meter beam, and the roll natural period is around 10.5 seconds or so without the slosh tank on it. So normally there's other videos on like how to set up a slosh tank, but largely what you're doing here is using panel slosh tank. We've got a box type here. I put in a 14 meter size to like cover a good amount of the beam of the ship, but again, I'm just making these up. Now I need this length, this pretty big length to help get that water mass. There's a little bit of interaction with the length and the fluid level. So as you're tuning it, the speed is kind of set by the water height, and then you kind of got to make sure you have a big enough box to get enough water mass. I'm just going to start off with 0.9. It's kind of arbitrary. So we go save and run. Now we have made a box and a panel mesh for that. And then we're going to do a potential flow solution with the sloshing flow inside the tank to get the characteristics of the sloshing wave going back and forth. So we use rad slosh tank for that, and then I've already got it pointing to the mesh that I made for that. Without getting into too many of the details here, we have a frequency range that we cover, and then we'll just run that. So we just ran the analysis there, and we go plot radco. We see this is just the box moving back and forth and what happens to the water inside of it. What we're looking at here is the pressure forces, like the wave pressure forces inside the tank in surge motion, in sway motion, in pitch and roll and yaw. So the thing about the slosh tank is that it's going to be swaying side to side as the ship is rolling. Although the main wave you see kind of showing both in roll and sway. But I tend to be looking at the sway wave here. So this damping is the first damping peak is what you should really be looking at. And that's going to be sort of like that big peak is going to be that first sort of like resonant wave going back and forth in the tank. So we see here it's at 0.75 radians per second frequency. And that is 8.3 seconds, 8.4 seconds. So it's kind of, it's faster. We want to slow down the wave a little bit so it better lines up with the roll natural period of the ship. There's going to be some interaction between the two of these things together, but what we basically want to do, this is the main point of this video, like the higher the water level, the faster the wave is, the lower the water level, the slower the wave is. So we'll go back to panel slosh tank here, and I'm just going to lower the water level a little bit to say like 0.7, and we'll run this. And we need to rerun our rad slosh tank here. Yeah, so now we're done. Let's look at radco. Okay, we're looking at sway here. So now it's like 0.65, 0.7. So let's say 0.65, 2 times 0.65. So we're like, 0.7. Yeah, so 0.65. Yeah, I mean, it's better than it was before. We're getting close to like 10, right? So I don't want to make the water level too low because then we're going to lose water and we're going to lose that mass that we need to influence ship motion. And then like that's what I really wanted to show you. But like you could quickly evaluate this, like just looking at the roll RAO. We'll do that really quickly just to show what it looks like. So for the ship model with only bilge keels and no tanks, we'll run this here. And this is the Beam C 0-speed roll RAO. You can see we've got a nice little well-defined roll RAO peak here as like at 4.16 kind of thing. That's with no slosh tank. I'll just make sure that I've run this with the latest slosh tank. So normally you would add a slosh tank in build ship. This is my slosh tank that I've got here, and I've just refreshed it with the latest water level and everything that I've got in it. So we'll go to Seakeep regular. I go to my slosh tank model here, and we'll run that. Plot motion RIO. So it's kind of a bit weird because the peak is still here, but what's happened is it's shifted to a much lower frequency. So now the roll peak, it's actually lower. Instead of being 4.13, it's 3.7. So it's lower, which is good, but it is at a lower frequency. The thing is, it's gone way up to like almost 16 seconds. And those waves are kind of a little bit less common. Now, meanwhile, at the old frequency of 0.7, the roll RAO has gone way down to like 0.6. So we kind of move things around a little bit. Of course, this is only the roll RAO. You know, you can do slosh tanks have many other advantages, like you can change the water level on the go depending on how things change. You might be adjusting the size of the tank. The gist of what I wanted to show today was like, if you've got a tank, you've got some constraints, how can you kind of fine tune it and get that sloshing wave close to the roll natural period? And I think that's what we've shown here by adjusting the water height. All right, thanks for watching.